Okay, so this lesson was pretty easy. So I'm going to do the hardest question from the worksheet. So for number 2, it says the particle travels along the y-axis according to the position function y of t equals t cubed minus 7t squared plus 8t plus 1 during the interval of 0 to 5, where t is in seconds. So A asks to find if at t equals 1, is the particle traveling up or down. So the first thing you have to do is take the derivative. So that would be 3t squared, minus 14t plus 8. So now we plug in t equals 1. So 3 times 1 squared minus 14 times 1 plus 8 equals 3 minus 14, or 3 plus 8 equals 11, minus 14 is negative 3. So the answer to this problem would be down, down because it's negative. Okay. So now the next question is, when does the particle reach its maximum height on the y-axis? So in order to find the height on the y-axis, we would need to take the derivative of the position function, which is right here already for us. So now we need to find what t equals in this function. So we can factor this out into 3t and then t. So we would, I know it's both negative, and then it would probably be 2 and 4. Yeah, okay. So now we can say that t equals, and we have to have our endpoints in there, which is 0 and 5. And then t equals 4 and 2/3. So now that we have our x-coordinates, now we just plug it into the original equation, which is right here. So now that we have that, we plug it in. So when t equals, oh my goodness, when t equals 0, the position would be 1 unit. Okay, so to save time, I pre-wrote my answers. So now that I know all of these answers, let's see, the first question is asking for the maximum. So to find the maximum, we just look at our answer for this part right here. And the largest number is the maximum height. The largest number here is 3.5. So they're asking for when and what is the maximum height. So when would be t equals 2/3, and what is the maximum height would be 3.5 units. So now the next question asks for the minimum height. So when it reaches would be, this is the smallest number, so it's basically the opposite to find the maximum. So for this question, it would be t equals 4, and it would be negative 15 units would be the minimum height. Okay, so the next question asks for the minimum and maximum velocity. The next two questions ask for velocity. So in order to find the maximum and minimum velocity, we take the derivative of the velocity equation, which is this one, and that would be 6t minus 14, which is also the acceleration function. So now we plug in, or now we solve for t, which would be t equals 14/6, which is the same as saying 7 over 3. So now we know that t equals the endpoints, which are 0 and 5, and 7 divided by 3. So now we have to plug it in to the original equation, which is the velocity equation. So now it would be 3 times 0 squared minus 14 times 0 plus 8. So when t equals 0, the velocity would be 8 units per second. Okay, again to save time, I just solved it on the side. So now for the minimum velocity, let's see, same thing. So minimum is the smallest number, which would be this one. So the answer would be t equals 7/3, which is negative 25/3 units per second. So that's the minimum velocity. This one goes up here. And so the maximum velocity would be t, which is the greatest number, which is 13. So t equals 5, and that's at 13 units per second. Okay, so the last two problems ask for the minimum and maximum acceleration. So in order to find that, we use kind of the same steps. So we take the derivative of the acceleration equation, which is just 6. So now we set it equal to 0, and obviously it doesn't equal 0. So the only numbers we can plug in are the endpoints, which are 0 and 5. So, oops. So now, if we plug in 0 and 5 into this equation, we get at t equals 0, it equals negative 14. And at t equals 5, oh, this is units per second squared. So at t equals 5, we get 16 units per second squared. So now, we just look for the biggest number and the smallest number. So the biggest number is 16. So for the maximum, which is this last one, the answer will be t equals 5 at 16 units per second squared. And for f, it would be t equals 0 at negative 14 units per second squared. And that's basically all there is to it.